Thank you. Good evening, everybody. I'm here to talk to you about Blockstack. We're going to talk about decentralizing the internet with single-page serverless JavaScript apps. First, a little about me. I'm a contributor to Blockstack. I work on the Blockstack Explorer, the portal, which is a JavaScript app, the macOS app, which is in Swift, among other things. And I'm also a serial entrepreneur. I've started several companies, which you can see here on my slide. I live in Hong Kong. So I've been there for about 10 years. Just arrived in New York, so I'm really happy to see everybody here today. I'm also a co-founder of the Bitcoin Association of Hong Kong. So what is Blockstack? Blockstack is the new decentralized internet where you own your own data and apps run locally without servers. So that's what Blockstack is, but first of all, I want to go back and talk about some problems that the old internet has. So I'm going to ask everybody, you can raise your hand, what are some problems that we have with the current internet? Lack of privacy. That's a great one. Reliability. In what sense?
I mean, like dropping out and speed varying and things like that. Like always connected is not really a realistic.
Yeah, that's great. Anyone else? Security. Give me an example of that. Cyber attacks. That's a great example. Trust. For example. So you have to trust a third party to tell you who you're really talking to. Great example. Okay, thanks guys. So the internet didn't turn out as we hoped. We've heard some of the problems from our audience here. Some other ones, honeypots and third-party attacks. Tracking and data harvesting. I just, about 15 minutes ago, loaded up my Twitter, and it asked me to agree to their new privacy terms of service, which basically said they're going to track my every move, my every device, my every app. Platform lock-in. You start doing your accounting on QuickBooks. You want to switch to 0. It's really, really hard because your data is in Intuit's servers. Restrictions on platform data access. You have data in a platform. You want to build an app on it, but you can't access it, or you can't access it in the way you want because of the business model of the person that holds the data. And power and the profits go to few. So we have companies like Google, Facebook, who just sort of suck in all of the value in the interactions. I mean, it happens, Microsoft, Apple as well. I mean, Apple makes tons of money and developers make a tiny bit of money. I mean, the value is just centralized in these large companies. So here's a few examples. I mean, look at, these are some of the world's biggest data breaches. So what you have is, you have companies that have tons of valuable data in their data centers. Many of these companies aren't tech companies, so they don't really have the tool set to protect them. And they're just like really great targets for hackers. You want to get data from the government, you go attack a government agency. You want to go get credit card information, you attack Target. Really horrible. Another example is Cloudflare. Amazing service, I love it, use it myself. But the problem is it centralizes the internet, tracks everybody, and it man-in-the-middles all your connections. So it decrypts your data. And that's a great place where if you could successfully attack Cloudflare, you could get a lot of valuable information and control over people's sites and identities. So this was an example. This is from a few months back. You may remember Cloud Bleed. So this is all the problem. The problem, as you may have guessed from what I just talked about, is centralization. When you have everything in one place, there's a lot of problems. A lot of benefits. Things are fast, easy with centralization, but a lot of problems. So what we're trying to do with Blockstack is we're trying to think, how can we decentralize this data, these services, in a way that lets us sort of have the same benefits that we have today, easy to develop, fast, great user experience. So imagine a world where you had no data silos, no middlemen, ad-free, no tracking, no passwords, and no lock-in. You can take your data, go where you want. So we can do better with centralization. And now I'm going to talk about how do we decentralize. Some of these things are using Blockstack technology. Some of these things are using other technology. I'm going to give you some examples. But one way we do it in general, though, is to take apps and data, which is now, so if you think back to maybe the 90s, those of you who are old enough, or the 80s, or even earlier than that, software was purchased in a box or in a download. You downloaded it and run it on your own computer. Your data is on your computer. And then, so in the past 20 years or so, we've moved to the SaaS model, where data and the app runs on someone else's computer. And why do we do that? There are a lot of benefits, right? It's easy to update. Users don't have to understand about installing and uninstalling and installing security patches. And the companies that run these apps can collect recurring revenue, and they can also have this very valuable data. So now we need to sort of figure out how we can take this and move it back to how it was in the 80s and 90s, but do it with keeping all of the benefits that we've gained from going to sort of the SaaS model. So we want to get rid of servers. We want to have a world where you have decentralized serverless apps, where you have a payment network that's decentralized, not like today's credit cards, where everything goes to Visa, MasterCard, American Express, but decentralized. We want to have a directory where you can find names. You know somebody, you want to look them up. You don't have to go on Facebook. You can trust something that's decentralized to find their names, their public keys, the data that they have about them. And we want open protocols for identity and authentication. So how do we do this? Well, we can use single-page JavaScript applications running on your browser to move apps to the edge. So instead of asking users to install apps on their computer, they can just load up a web app, right? And that web app doesn't necessarily need to run any code on our server. It can run it all in a browser. We have the technology today. For payments, we can use Bitcoin or other cryptocurrencies. Who here has Bitcoin? Raise your hand. Anybody? Cool. Who has heard of Bitcoin? Okay, cool. So yeah, we can use Bitcoin or another cryptocurrency for a decentralized payment network. We can use Blockstack Core, which is a product technology from Blockstack, as a directory for names and pointing those names at various pieces of data in a trustless manner. And we can use sort of a specification or a technology called Blockstack ID, which is a protocol that lets you do identity, login, authentication on top of Blockstack. So now what we're going to do is we're going to go through some code examples of how you use this. People here are Node developers for the most part, so we're going to talk about JavaScript. There you go. So first of all, we're going to start with adding payments to your JavaScript app. How do you add money to your app? Well, one way is you can sign up for a Stripe account, and you can follow their documentation, and then connect to their service, and it'll work really great. You can accept credit cards. But what if you want to have more freedom, more flexibility? You want to programmatically use that money in a way that maybe doesn't really conform to Stripe's terms of service, or in ways that don't make economic sense with the fee structure of credit cards. Well, you can add a Bitcoin wallet to your app. And it's actually really easy to add a Bitcoin wallet. I mean, I was personally surprised myself until I actually did it. So I'm going to walk you through how to do that in a couple slides here. But first of all, let's talk about how Bitcoin works. To give you sort of a very basic overview, there's things called addresses, which you can think of like an account or your credit card number. And these addresses are actually just public-private key pairs. And then these key pairs are used to sign transactions and to sort of like signing a check that says, I take the money I have here and send it somewhere else. That's sort of a really high-level overview of how that works. So to add this to your app, it's actually quite easy because there are these really great JavaScript libraries that exist. And we're going to show you how to do that right now. So the first thing you need to do is you need to create a public-private key pair. And you do that, here I'm using Bitcoin JS lib. It's really easy. You see 4 lines of code. You create a wallet. When a wallet is sort of lets you generate deterministically a bunch of key pairs. And you get some random information from the random number generator in your browser, which uses the Web Crypto API. Or on Node, it uses OpenSSL. And then you call the get address function, and you get an address. And the address has a private and a public key pair. So already, what you can do is you can take this address, you can display it to your users, and you can say, hey, like, send some Bitcoin to this app, right? Or you can send this address to perhaps another API or to another service that wants to be able to pay your app money. So for example, maybe you're selling services to other machines. So 4 lines of code, you've added money to your app already. Next, how do you spend this money? Well, spending the money is a little more complicated because you have to pull in some state from other places to make the proper transaction. But again, it can fit on one slide of a presentation. So what you do is you want to build a transaction. And so to build a transaction, you need to figure out how much Bitcoin is in the address that you're trying to spend. And that Bitcoin could have entered that address through one or more transactions. So what you have to do is you have to go through, from an external source, you have to get a list of all of the transactions that haven't been spent that were sent to that address. And then what you do is you go through those and decide which ones you want to use and you want to spend, and then you add them to your transaction. So that's the add output. So you have tx add output. And those of you who are very sharp will notice there's a typo. That shouldn't be recipient address. That should be a different value. But I'll leave that for you to figure out at home. And what you do is you add these unspent transactions to your transaction, and then what you do is you send some of that money to the recipient address, and then you send the rest of that money to another address that's in your own wallet, because that's your change. So if you're sending 1 Bitcoin, right, and I want to send 1 Bitcoin to this gentleman here, and maybe I originally had 2 Bitcoins, what would happen is there would be actually 1 transaction with 2 outputs. One would be one Bitcoin to him, another would be 1 Bitcoin back to myself. And then once you generate this transaction, you sign it, which is using your private key, the private key of the address whose Bitcoin you're trying to spend. And then you take that transaction, which is some hex encoded characters, and then you post it to an external service. There are many of these available on the internet. You don't have to pay for them usually, and what that does is those services take the input and then broadcast it on the Bitcoin network. And then you've sent money. You sent money to your recipient, and then after a period of time, usually an hour or so, that person can be sure that the Bitcoin you sent to them is now theirs to use for other things. So very simple. Any questions on how to make a Bitcoin wallet? This is all running, so if you're using Node, it's running in Node. If you're running this in your browser, it's running in your browser. On the user's computer. It's running on the person who's sending the money. The question is, where is the person getting asked? Well, you'd have to write code to do that. Like, so in this instance, you see there's a variable amount to send. Nothing. That's why they have to trust you. And that's why we want code running on their computer so that people can inspect it. That's why open source is very important because anybody that controls your private key can send your money. So it's sort of like a private key in anything else, whether it be PGP or your password to your bank, right? If I have your password to your bank with maybe your security device, I can spend money in your bank. So it's sort of the same concept. You're trusting whoever has your private key, whether that be code or another human being. Does that answer the question? No?
Or I just clicked on a link that said that had a pretty picture on it.
Oh yeah, so the question again for everybody else is like, what if I clicked on sort of a link that had some rogue code in it? And the answer to that is you shouldn't ever put yourself in the situation where something like that could access your private key. So it's sort of out of scope for this discussion, but there's a whole bunch of ways to protect private keys. You can get hardware devices where if you want to make a Bitcoin transaction, or what we'll talk about later, a Blockstack transaction, right? You can actually insert a hardware device into your computer, and then the key never leaves that device. It signs the transaction, sends it back to your computer, and broadcasts it. So there's a whole bunch of ways you can protect these keys, and it is very complicated. You're right. It's very If you have a private key on your computer, one of the things we really worry about is like, what if rogue applications, code, viruses get access to that? Because yes, that can spend all your money. Yeah. Thank you. OK, cool. Moving on. Let's talk about decentralized authentication and identity and how we can add that to our apps. Our goal is to not have to use Facebook. And why do we not want to use Facebook? Because, well, for example, if Facebook is down, our app doesn't work. And so for those of you who use Tinder, for example, like you'll find when Facebook is down, you can't swipe left or right because you can't even log into the app. And that's bad for users, and that's bad for it's bad for businesses, right? Because you have counterparty risk. You build on someone else's API or services. If they change their terms of service, they turn off their API, they just have poorly run servers, then your business is down when their business is down. And that's risky investment. So to do this, we use Blockstack. And we're going to talk about a little bit about what Blockstack is. First of all, I'm going to show you how easy it is to write the code. Then I'm going to go through sort of a brief overview of how Blockstack works under the hood for people who are interested. So without Blockstack, we have a world of servers and databases that run on other people's computers. And we have to sort of build these identity management systems. So people that write web apps probably know, like, one of the first things you have to do is decide, OK, well, I need to like create a username system. I need to have like something to recover their password. And there are a lot of plugins you can use for this. But there's a lot of boilerplate code that like gets recreated over and over and over. And one of the ways people have tried to solve this are using things like login with Facebook, login with Google, login with iCloud. You can just add a plugin, but then you've outsourced all of your user management to someone else with all the risks of building on someone else's service. They own your customer, they own your data. Payment systems to build, no encryption. It's very hard to encrypt data that you don't control. Most of these third-party services we use, we're not really sure how they store our data. And pretty much all of the time, they have access to our data. They can look at our photos, they can look at our transactions, they can do whatever they want with our information. And oftentimes, that's part of their business model. So even if they wanted to make it so they couldn't read our data, they wouldn't be able to do it because it would destroy their business model. No data integrity. We often don't necessarily know like if the data that we provided originally is still the same data when we get it back. And with Blockstack, we can have a world where it's serverless. We're not trusting other people's computers. We can have these great personal storage APIs where people, like we have information like our photos, for example, and we can use this information across a variety of apps. We don't have to just depend on Google's apps or Apple's apps to access our photos and to manipulate them. Built-in identity, really easy, the one-click login. You don't have to, easy for developers, you don't have to write a lot of code. Easy for users, you don't have to fill out forms and manage password managers. Payments built in, encryption built in. Easy for developers to use. Encrypting data is seamless, right? You don't have to deal with private keys and all of the issues like this gentleman pointed out about how it's really easy to lose private keys or to let them be accessed by rogue code. Signatures that are built in, we can ensure that data that we provide or data that someone else sends us was actually sent by that person and it hasn't been changed in transit. So, how do we make a login system with Blockstack? Well, you can see it's actually easier than adding money to your JavaScript application. You would npm install Blockstack, and then you'd write this one line of code that says Blockstack login user. And then what would happen is this library will generate an authentication request, which is a Java Web Token, and then you would be directed, the user's browser would be redirected to their Blockstack portal, which is some software that's running on their computer and displays in their browser, and it allows them to sort of approve or deny your app's login request, and then decide what sort of information and access the user wants to approve. So here's an example of a sign-in request. So you can see in the background is Blockstack portal, and here in the foreground we have the approval dialog. And the really interesting thing is that the data that is displayed in this dialog is actually verified. So what we do is we make sure that the login request is actually coming from the domain that it claims that it's coming from. And coming in the future, we'll be able to use decentralized names with their own public-private key pairs to ensure that, that you can actually make sure that your app's code and the login request come from a known source. Very important for trust. So once the user approves our login and we're sent back to your app, the next thing we want to do maybe we're making a photo sharing app, or an app where we can sort of add, I guess, like we can fix my face and add some hair to my head or something like that, right? So how do we get the user's photos? Well, it's really simple because the user has decided that they want to share the collection of their photos with you. So very easy. We just call user.getPhotos, and then we get an array back with some of their photos, and we can choose to sort of manipulate them, resize them, change them, do whatever we want with the photos. And then once we've changed them and modified them, we can put them back into the user's photo store collection. So very simple. This is sort of the world we envision. Very simple API. It's easy for people to use. Not a lot of boilerplate code. But keep in mind, this is all running on the user's computer in their browser. Oh, I see some questions here. This gentleman first. And yeah, please go ahead. Sir.
After you do a login, you get the job, the JWT. Are you past that in every subsequent call that you're performing so that it's always being validated in any type of request that you're doing?
So the question is, the response, the token that you're getting back as a response, are you using that in every subsequent request? And the answer is, so you actually sort of get two tokens back. You get a response token, and that response token has, what it has is it has a signature on it. It has a decentralized identification, so a DID, decentralized identifier. And what that actually is that's the address, the Bitcoin address that owns the name of the user. We'll talk about this a little bit more once we get into how Blockstack works. And then there's also a name that you're claiming is yours. So maybe my name is Larry, and I claim that I'm Larry.id, and there's also the address. So then what the app does, this app that has received the login request, what Blockstack's JavaScript library does behind the scenes is it goes through and it looks up whether or not the address that has signed the response actually, in fact, owns that name to make sure that the person is who they claim they are. And it also, so the second token that gets included is what we call the core session token. And what that is that's a token with a set of limited read-write capabilities that are sort of already in it. And then you would, yes, to answer your question, yes, you would provide that token, that second token, when you make requests to the Blockstack user's core node to, for example, get their photo collection or to write to their photo collection. Yes. Thank you.
I guess the question I was going to ask is that get photos essentially reaching into like a Blockstack wallet? Do you have a number of collections in it, or is that a self-held wallet, or like so those photos are being stored on the user's computer and it's allowing your service to use them.
Mm-hmm.
So where does like the wallet type thing?
So there's a whole storage layer called Gaia, and that's so the user, in using your app, the user will first install Blockstack on their computer. So that's just like, so it's an app, it's a point-and-click app, right? And it runs a bunch of things. One of those things is a Blockstack core node. And what that is that sort of allows them to have a copy of all of the decentralized Blockstack world on their computer, so they can independently verify that things are as people claim they are. And also there's a storage layer, and that storage layer stores the user data, and the user gets to decide where they actually want to store the data. So some people can store it on their disk, some people will choose to store it in Dropbox or Amazon, or maybe their own server that they run. And so when you get the photos, what happens is a request goes to the Blockstack core node, and then that figures out like where your user has stored the data, and then it goes and gets them and then returns them back. Cool, thanks. One more? Yeah, we have a diagram coming up in like next slide. Yeah, yeah. So the question was, how do other apps interact with each other? And so I can give you one example. So in this instance that we just talked about with photos, right? So apps could interact with each other because they can interact with data that's in the collections that the user exposes to these apps. So that's one method that apps can use to interact with each other. Does that sort of help at all, or? Well, how it happens is another app. So how would apps work together on this data, right? So for example, say I want to, like, first of all, I want to mark up, I want to add a hair to my head. So I take a photo of my head, right, and I put it in my Blockstack storage, and then I load it into a photo editing app where I can like paint some hair on top of my head. And the next thing I want to do is I want to share that with all my followers on a decentralized Twitter, right? So then I would load up the decentralized Twitter app, and then I would make a new tweet, and then that app would make the same call that I used in the editing app to get the photo that I've just edited, and then it would share it. Please. Mm-hmm. I'm sorry, can you say that one more time? Mm-hmm. At the moment, we don't have, that's something we have in the roadmap, like I think either towards the end of the year or next year. At the moment, the answer is no, but in the future, there will be some sort of mechanism for that. Cool. One more. Oh, his question was, I'm sorry, his question was when a new user joins your app, so for example, a decentralized Twitter, right? Like, a new user joins the app, like how do people in that app get notified there's a new user using that app? And the immediate answer is that as of today, like, we don't have a mechanism for that, but it's something that we have on our roadmap, either for later this year or next year, I believe. Cool. One more question, and we'll talk about architecture.
So, not to play devil's advocate,
Yeah.
maybe play devil's advocate.
Please, by all means, play devil's advocate.
You talked about locking, right? And you're being locked into the authentication that you provide. So theoretically, if everything's built upon Blockstack, you're locked into Blockstack.
Mm-hmm.
Whereas, what about some of the other approaches in the market, say, for example, IPFS, where
Mm-hmm.
it's a file system that you can still access through their gateways,
Mm-hmm.
but in their protocol, you choose the encryption, you choose the blockchain contracts that you want to use. I think they promote that freedom, but like, you get to dictate that,
Mm-hmm.
and you satisfy the same thing without blocking.
Mm-hmm.
Is that something that you guys are considering, or
Mm-hmm.
is it sort of the Blockstack way?
Oh no, we're not. I mean, we're definitely we're against lock-in, right? So I mean, so everything we do is open source, and we're participating in the Decentralized Identity Foundation, which is sort of a group of companies that are and projects that are coming together to sort of like create standards around all these things that we're working on. So have a standardized name layer. And another thing that the Blockstack naming layer does is it's blockchain agnostic. So right now, so the production namespace is on Bitcoin, but we support Ethereum. Pick your blockchain. All you need to do is write a driver for it, and we'll be doing that later this year for some other chains as well. I mean, I think it's too early right now to sort of declare like one blockchain as a winner. No, and IPFS definitely. I mean, we see that as like that's a great storage layer, right? So that's something you could, maybe you want to have your data on S3 IPFS BitTorrent, right? Like that way it's replicated several times, and then you can, based on what's the best performance or what's available, you can get your data from that. Does that help? Cool, thanks. Okay, so let's talk about architecture. So up here on the screen, you'll see a lot of different things. And so I'm going to sort of walk you through the different layers that make up Blockstack. And then if you have any questions at all, please raise your hand. I mean, some of this. First of all, let me like get a show of hands. Who sort of knows how blockchains work at all? Yes, no? Oh, wait, cool. It's a lot better than the meetup I did in London. Cool. Way to go, New York. Okay, so Blockstack is sort of based sort of on layers, sort of like the current internet, right? So we have layers like the hardware layer, the physical layer, right? Ethernet, right? And then we have like on top of that we have TCP, IP, and then TCP, right? And then our application layer. So we sort of have a very similar sort of design philosophy in Blockstack. And so we start out at the blockchain layer, right? And so right now the blockchain layer for Blockstack is Bitcoin. Bitcoin is currently the most secure, sort of most decentralized blockchain, and so that's why we currently use Bitcoin. And so what we do is on top of the blockchain layer, right, on top of Bitcoin, we create what is called a virtual chain. And that virtual chain on its own looks like a blockchain. And the way the virtual chain works is it inserts specially encoded transactions into the Bitcoin blockchain that sort of have different operations. And then Blockstack, virtual chain and Blockstack Core read through the Bitcoin blockchain and then parse out the transactions they understand and sort of get rid of the transactions they don't know. And then use those transactions and the operations that are in them and the data to sort of create a state, a database of the Blockstack world. Everybody with me so far? So Blockstack transactions in Bitcoin, like Blockstack Core reads through these transactions and uses the operations that are in them to create its own database. That database is a database of names and the data at which the names point. And when I say the data at which names point, I'm actually talking about a hash of the real data. So what you have is names pointing at hashes. We call it the value hash. And this hash is just the hash of the data the name is pointing at. And then, okay, cool. So on top of that, we have another layer, which here we have, we call the routing layer. Now we call it Atlas. Atlas is actually a P2P storage system. And what that system has is, it has a bunch of zone files. So zone files are sort of structured like the good old-fashioned ICANN DNS system we know and love, and sometimes don't love. And in those zone files, there's information about how to reach additional data from the user. So what we store at the routing layer, the Atlas layer, the Atlas system, are these zone files. And then so the hashes of the zone files are in the Bitcoin blockchain, and then the zone files are in Atlas. And these zone files in Atlas are replicated among all Blockstack nodes, so that you can always be sure if your data won't be lost, right? Because if a node goes down, when it comes back up, you can get those zone files from an existing node. And then we have a storage layer called Gaia. And this storage layer, as I talked about before, is sort of based on, it's platform agnostic. There's a whole bunch of drivers already. And you can choose where you want to have your data stored. So you can store it on Dropbox, you can store it in S3, you can store it in IPFS, you can store it on your disk. You could even print it out and store it in an envelope, I guess, if you really wanted to. Any questions? So that's sort of what's happening up there on that graph. So what Blockstack tries to do is we try to sort of abstract away this complexity, because there's a lot of things going on there. We don't want developers making apps to have to really think about this. This is implementation details. It's important to understand how it works when you're sort of judging, like, is this decentralized? Where is the trust in the system? Who am I trusting? Am I trusting me? Am I trusting Larry? Am I trusting Blockstack? And hopefully the answer will come away with is, no, you're not trusting us. You're not trusting me, of all people. I wouldn't trust me. So we want to take all these services and make it really easy so that the apps have storage, authentication, identity naming, and access to blockchain from a really easy-to-use API. So Blockstack it's not a new thing. It's battle-tested. We've been running a production system for over 3 years. Originally, we ran a production system in Namecoin, which is an altcoin that was originally created to provide DNS services on a Bitcoin type of system. We ran into some problems with that. There was an instance, it turned out to not be decentralized because it was controlled by basically one miner. There was some sort of problems with the code in that like not a lot of people used it, so we were the ones that would find the bugs in the code and then have to fix them, as opposed to something like Bitcoin where lots of people use it. Like it's an extremely valuable system. So 3 years in production, we moved our production system from Namecoin to Bitcoin. Not sure if that's the world's first blockchain to blockchain migration, but it's probably one of the earlier ones. Over 70,000 names registered, domain names, usernames that you can use to log into your apps. And then we are the largest non-financial blockchain protocol. So we have 50% of the Bitcoin blockchain's non-financial transactions. And it's not just users that have been sort of looking at our code. A lot of academics have been looking at Blockstack as well. So these are some of our published papers, peer-reviewed academic papers, not white papers released to raise money. And we have some of the community members here. So the creators of Blockstack, Manib and Ryan, are up there on the screen, along with some of the other core developers, Jude, Guy, some of the people who have helped from other projects, Elizabeth of Lightning Network, lots of people who have contributed to this project. And we have the growing developer community. This is actually a few months old. We're way over 2,000 now. So we hope that you'll come and join our community and sort of like give us your ideas of what sort of apps should be built in decentralized internet. Perhaps hack on our code, send some pull requests. Love to hear what you're thinking. So I'm open for questions now. This is my contact information. You can follow me on Twitter, email me. I'm usually in Hong Kong. If you're passing through, like hit me up and we'll meet up for coffee or something. Cool. Thanks. Any questions?
Yeah. So every time I think of Blockstack and how it's all put together, one question comes to mind, which is when you have storage which is spread out among all the providers, you kind of choose it. If you have an envelope, you save it, whatever it is. How do you optimize web performance and make sure that you can deliver a fast experience because that's what users want? And that's one of the benefits of owning and centralizing stuff at the moment.
Mm-hmm. Yeah. So the question is, when you have everything decentralized, how do you guarantee performance, like speed, availability to your end users? That's a really good question because that's something that I've come across with our earlier implementations. Because what would happen is like someone would upload their avatar, for example, on Amazon S3, which is really like in the US, which is really fast if you're here in New York. But if you're serving something from the US S3 over in Hong Kong, it's really, really slow because Amazon doesn't intend you to use it like that. They intend you to put it behind CloudFront, right, their CDN product. So the answer is it's really a new field, so it's going to be challenging. So one of the great benefits of Blockstack in terms of speed and performance is that it's running on your user's computer, so they don't have the round-trip delay of having to go back and forth for updates. But the downside is depending on whose data they're accessing, it may not have the access characteristics that are ideal. So I mean, there are some approaches you can take to this, right? You can publicly available data, you can pre-index or you can cache, right? So that's one potential approach for that. You can encourage, I mean, you or we or whoever's building the system can encourage users to replicate their data over several different storage providers, so Dropbox, IPFS, BitTorrent, right? And then the code can sort of, based on current conditions, find the data from the source that provides the best performance. But yeah, it's definitely a challenge, and there's going to need to be research and trial and error and figure out how we can optimize for this. Yeah, thanks.
So I'm kind of blockchain new, but like to do non-financial transactions on the blockchain, like there's a fee, right, that miners expect to get paid when they're dedicating their computing power to this, right?
Yes.
So I'm thinking either you are able to store like some sort of metadata in actual financial transactions, or someone's paying a fee.
Yeah. Okay. So the question is, I just talked about how we are the largest non-financial user of Bitcoin, right? And so the gentleman asked, to use Bitcoin, you have to pay a fee, right? Because otherwise, if you don't pay a fee, the miners won't mine your transaction. And that is 100% correct. So perhaps I was a little bit misleading. We do pay fees. So when I say non-financial transaction, I'm talking about a transaction where the intent of the transaction, the overriding intent of the transaction was not to send money to someone else. So in Bitcoin's case, we burn the Bitcoin, so we send it to an address where it can't be spent. So we're clearly not trying to send money to anybody because no one can spend the money. But yeah, we do pay the fee, and that fee is increasing a lot, as we noticed today, right? Because of the price of Bitcoin. So we have a whole bunch of approaches in the future that will help us mitigate that fee and make it so that it's either a lot cheaper or potentially free by things like subnames and other methods. But yeah, we do pay a fee. Any other questions? Oh, please.
What are potential network effects on blockchain besides for security as community grows? That we would experience as a developer and as users?
Well, I mean, as a developer, the network effect is like as more people use it, then you're more valuable, right? Because like more people want to hire you. There are more tools that are created around this, so it's like any ecosystem, right? If everybody's using jQuery, then like it's much easier to use jQuery because you can find answers when you have problems. From users' perspective, I think that the network effect is that as more people build on this, it becomes more convenient. So it's admittedly not the most convenient thing right now. If your only thing you're doing on Blockstack is using one app, right? You know, maybe that's like kind of a pain because you have to download the software or like think about this. You have this cognitive overhead just for one app. But as more people use it, then that sort of that overload that's not a problem anymore, right? Because like you use it all the time. So I think for users, the network effect is like the more people that use Blockstack, the easier their life gets, right? Because they don't have to handle passwords anymore. They don't have to do password managers. They have their data in one place where they control. But yeah, that's the network effect, is that the more people that use it, the better it is.
So you said that you have to install like the full Blockstack app on your computer,
Mm-hmm.
and you have to set up where you want to store data, right?
Yes. Oh, so the question is, do you have to? Oh, you go ahead.
So let's say we all know how to code, I assume. So for us, would be an issue. But what about people who do not know how to code? With people who would like maybe can download an app on their phone, that's it.
Mm-hmm.
Like for those people, the barrier of entry would be really high to even use our apps.
Well, I don't think it's. So in terms of downloading an app, it's not any different than downloading an app on your phone, right? Like it's, on the phone you'll be able to go. We don't have a mobile app out yet, but you'll be able to go and download it in the App Store, right? And so it's right now downloading and running Blockstack on Mac OS is no different than downloading and running like Sketch on Mac OS.
But what in terms of configuration? Like if they have to choose S3, Dropbox, or whatever.
Yeah.
Like, do you trust those users that they're able to make those decisions?
Well, I think that if I'm a user that's not a developer, I would probably just click on whatever one whose name I recognized, right? Like, oh, I have a Dropbox, click Dropbox. So, I mean, hopefully the only configuration you have to make at the moment are to choose a password to secure your wallet, right? That holds your name and your Bitcoin. And we make it really easy. We even offer the option of sending an encrypted backup of that to their email so they don't lose it. But that's really the only thing, that and connecting storage. The only things, and we're going to be making it so you don't even have to connect storage to get started. So really it's just choose a password, enter your email, just like anything else. Yeah, so we're trying to make it like as simple as possible. And so that's really where the challenge is, I think. Because a lot of the stuff we're doing is like sort of PhD level stuff. Most of the people are working on this have PhDs. And how do we take what's relatively complicated and sort of cutting edge stuff and then simplify it down to like user get photo, right? User put photo, like, and also for users as well. So yeah, thank you for that question. Anything else? No? Well, it doesn't exist right now, so it would depend on how you architected the app. No, you wouldn't. So I guess I hadn't really thought about this a lot, but in terms of how I would design a decentralized Twitter, right? You wouldn't, first of all, you don't ever need to download the whole blockchain. You can. Somebody who wants maximum trust, like I don't want to trust anybody, I don't want to trust anything. Like what they would do is they would install a Bitcoin node on their computer. They would modify their Blockstack installation, have it point at their own Bitcoin node, and then they would generate all of the Blockstack history, right, from their own Bitcoin node. And they would also make sure they verified the software when they were downloading it and all this other stuff. The average user will probably use a Bitcoin node that's run out in the cloud, which is how most like Bitcoin wallets work as well. So there's slightly less trust in that instance. And you won't actually have to verify all of the Blockstack information as well. You can either use public nodes or you can download a pre-generated database and just verify it. So to use these apps, no, you don't have to download all the information at all. What would probably happen is that that a Twitter app would publish, people would publish all of their tweets in a way that's accessible, probably a URL of some sense, and then they would publish, each URL would have a number, and they'd publish maybe a list of all of the numbers of their tweets, maybe in reverse chronological order, and then clients would just grab the first, the 10 latest tweets or something like that, and display them. So it really just to be a sense of, okay, I have to make 10 HTTP requests, or like maybe one, right? Does it help? Answer the question? Cool, thanks. Sure.
You have a metadata editor, because like you're basically holding a lot of the metadata that the application is using and just kind of getting it back, deciphering, and then knows where to go and retrieve files, get different aspects of the application. So it seems like you have to have this whole editor that goes that's associated with your application to do all that configuration. Is that correct, or
So the question is, do you have like a metadata editor to sort of, again, correct me if I'm wrong, to edit the configuration state of the applications that are built on this?
really namespaces and associating that with values? So how does that occur?
So I don't think you don't necessarily need to have an editor. I mean, what we provide two types of storage. So one is collections, and then another is a data store. And so data store you can think of as like the private area for your app to write whatever it wants, only accessible to your app. So in that instance, apps would store their configuration data in whatever method made the most sense for that app. It's their own little personal hard drive. They can write whatever they want to it, only they can read it. So I don't think, maybe perhaps standards will emerge as to sort of best practices, but at the moment, we don't really have any particular metadata configuration for apps. Thank you. Anything else? Oh, we have stickers in the back. So Patrick, who is my colleague back there, is manning the sticker table, so please grab some stickers. Yeah. Any other questions? Thank you.